This example demonstrates how we can craft and send an ARP request packet from the Ubuntu system to the Windows 7 system. Before we do packet crafting, we understand the structure of an ARP request packet, for which we open a wireshark analysis of an ARP request. It can be seen in the screenshot. The ARP request packet uses an Ethernet header as well. This is because the address resolution protocol works at layer 2 of the OSI model, and it requires an additional Ethernet header or the type of header which is used for that particular communication. So in this case, we are using an Ethernet header. If we go inside the Ethernet header, we can observe that the source MAC address is that of the initiator's MAC address, which is 00E01C 3C22B4. The destination MAC address is a broadcast. We go inside the ARP request packet. There are different fields like hardware type, protocol type, size, protocol size, opcode, etc. Of this, the important values are the opcode, which refers to the type of ARP packet, which in this case is the ARP request packet. Then you have the sender MAC address, which is the initiator's MAC address, sender IP address, which is again the initiator's IP address, the target MAC, which is not known and which is to be provided by the target IP address. Now we go to Scapy on Ubuntu and craft the packet. We start Scapy. First step is to create an Ethernet header. The second step is to associate the source address in the Ethernet header with that of the initiator's MAC address, which is the Ubuntu system's MAC address. To identify the Ubuntu system's MAC address, we type in the command ifconfig. It is 00E01C 3C22B4. E01C 3C22B4. Next, the destination address would be a broadcast. Which is denoted by all F. Now that we have created the Ethernet header, the next step is to create the ARP header. Type in the command ARP equal to ARP. To understand the different fields inside the ARP header, we use the command lsarp. We need to now associate the opcode with the value 1, which would signify this is an ARP request packet. Now, the ARP hardware source HWSRC corresponds to the MAC address of this particular system, which is 00E01C 3C22B4. The hardware destination field, which is HWDST, is null, signified by all zeros. The hardware source address, which is a sender IP address, is the IP address of the Ubuntu system, which is 192.168.1.25, and the target IP address, which is abbreviated as PDST, will be 192.168.1.100. Now we need to send this packet. To send this packet, we need to send it at layer 2, for which we use the command sendp. Before we send the packet, we start Wireshark on Windows 7 to analyze the received packet, for which we apply a filter ARP and we say start. Now we go back to Ubuntu and send the packet. Can be observed that the packet has been sent. We stop the Wireshark here. We go to the correct packet. This is the packet which has been sent by the Ubuntu system. It can be observed that the source MAC address is in the Ethernet header is 00E01C 3C22B4 and the destination is a broadcast. Similarly, the sender MAC address is that of the initiator's MAC address. Sender IP is 1.25, target MAC is null, and the target IP is 1.100, which is a Windows 7 system. The Windows 7 system on receipt sends the corresponding ARP reply, which can be observed here, with the target MAC address as the appropriate value. This is how we can craft an ARP request packet.